So this one is May June 2014 paper 3, because before 2016 the combination was 1, 3 and 6. Now you will select 2, 4 and 6, but before 2016 it was 1, 3 and 6. So in the circuit shown in figure 9.1, a resistor is connected. Resistors can be connected between terminal P and Q. So we can have resistor here between P and Q. The EMF is 6 volts. Calculate the current shown by the ammeter, because this ammeter is next to the battery, so we need a total current. When a 12 ohm resistor and 4 ohm resistor are connected in series. So if 12 ohm and 4 ohm resistors are connected in series here, so one of them is 12 ohms and the other one is 4 ohms. They're connected in series. I need a current here. And to find this current, as we know, this ammeter is next to the battery, so it means we need a total current. So if I need a total current, we have this formula according to the resistance is always a ratio between voltage and current. When we divide voltage divided by current, what we'll get? We will get resistance. But we need a total current. So if we need a total current, we need a total resistance. What is the total resistance of a circuit when 12 ohm and 4 ohm resistors are connected? So the total resistance is equals to 16. So total resistance is 16. What is the total voltage of the circuit? What's the total voltage or by EMF of the circuit? That's 6. So that's equals to 6. And we need a current I. So current I is equals to 6 divided by 16. What's the answer? 6 divided by 16. 6 divided by 16. So the final answer is 0.375. So it will be 0.375 amperes. Is it clear, the first part? Because in the question, calculate the current shown in ammeter, and ammeter is next to the battery. It means we need a total current. For the next circuit, for the next part of the question, they mention now P and Q are connected in parallel. So you have connected in parallel between P and Q, means 12 ohm and 4 ohm are connected in parallel. You don't have to draw. I'm just drawing it to explain the idea. They did not say draw, so you don't have to draw this. So 12 ohm and 4 ohm are connected in parallel, and again we need a total current. So if we need a total current, we have the formula R is equals to V divided by I, or you can also learn as V is equals to IR if you want to write all of them in numerator. So what is the total voltage? The total voltage is 6. We need a total current. What about total resistance now? What is the total resistance of this circuit when they are connected in parallel?
Same, C.
So how much it will be?
60.
When they are in parallel, the total resistance, the formula for total resistance is product divided by sum. When two resistors are connected in parallel, to find the total resistance, the formula is the product of the two resistance divided by sum of the two resistance. So product divided by sum, what is the product here? It will be 12 multiplied by 3, which is equals to 36, and divided by sorry, 12 multiplied by 4, which is equals to 48, divided by 12 plus 4, which is 16. So it is 48 divided by 16, that's equal to 3 ohms. So 3 ohm is a total resistance. So I will put 3 here. And if this 3 is multiplied, I need a current. So it will be 6 divided by 3. What's the answer for 6 divided by 3? The current will be 2 amperes. So you can see when the two resistors were connected in series, because in series the total resistance of a circuit is high, so the current was only 0.375 ampere. But when they're connected in parallel, the total resistance of a circuit decreases, so the current increases. Is it clear? This question first, first question part A1 and 2.
Yes, sir. Assalamu alaikum. Sir,
Yes.
just small question I forgot. In series circuit, voltage doesn't change or current?
In series circuit, current is same, voltage divide. In parallel circuit, voltage is same, current divides. And if two
Okay,
resistors, yes,
like I forgot why again.
because what happened, there is only one passage for the charges to flow. If the charges have only one passage to flow, so that they cannot divide into branch. So if 2 ampere or 0.375 ampere is entering from the circuit, how much it will flow through first resistor? 0.375. How much through second? 0.375, and then it will return. But voltage is how much energy transfer. So example, if it is written 6 volts, so what does it mean? It means if there is one charge, how much energy it carry? It carry 6 joules. So when it passes through the first component, it will lose some of its energy. When it passes through the second component, it will lose remaining energy. So before entering example, it was 6. When it passes through example, it is 3. And then passes through this one, it is 0. So how much energy transfer? 3 volts or 3 joules per coulomb. And how much energy transfer in the second one? 3 joules per coulomb. So voltage
Okay, sir.
divides, but the current is same. But in parallel, because the charges have multiple ways to flow, so some of the charges flow through one path, and remaining charges will flow through the other path. That's why the current divide in parallel, whereas voltage is same in parallel.
Okay, sir.
Now,
Understood.
okay. State the relation between resistance and length of a wire for a constant cross-sectional area. Means you have two wires of same areas but different length. What is the relation between them? Relation between resistance and length. Directly proportional or inversely proportional? So resistance and length are directly proportional. That's right. So you will mention here directly proportional. Directly proportional means if you increase one quantity, the other will also increase and the ratio between them will remain constant. What is the relation between resistance and cross-sectional area? Resistance and cross-sectional area, if the length is constant, means you have two wires of same length but different cross-sectional areas. Which wire will have high resistance? Like if I increase the area, what happened to resistance? So if we increase one quantity, the other will decrease. So we call that as inversely proportional. Is it clear? When increase one quantity, the other also increase, we call directly. If you increase one, the other is decreasing, we call that as inversely proportional quantities. In the next part, the 12 ohm and 4 ohm resistors are made up of same length and same material. I told you when two wires are made up of same material, then you can use this formula. What is that formula? R1 A1 over L1 equal R2 A2 over L2. Because they will, if they're made up of same material, they will have same resistivity. So we can say R1 A1 over L1 if we are comparing the two samples which are made up of same material, so equal to R2 A2 over L2. This formula is only valid, keep in mind it is only valid when two samples, two wires are made up of same material. Now what we need a ratio of their cross-sectional area. Cross-sectional area of 12 ohm divided by cross-sectional area of 4 ohm. We need this answer. Now in the question you can see a 12 ohm and 4 ohm resistors are the wire of same length. So they have the same length. So how we can solve this question? If first resistance I take 12, so R1 is 12. Area I don't know, so that's A1. What is the length? Length we don't know, but we know both have the same length, so I'm saying L. R2 is the second resistance, which is 4. Its area I don't know, so I'm saying A2. And length L2, I'm also saying L. Why I'm saying L? Because in the question they mentioned they also have the same length. So if they have the same length, I can just put the same number, same variable, same symbol. So if I solve this L will cancel with L. And I need a ratio between 12 ohm divided by 4 ohm resistor. So this is the area of a 12 ohm and this one is the area of the 4 ohm. So I need A1 divided by A2. So if I need A1 divided by A2, 4 is already there. 12 will multiplied, other side it will divide. And if I solve simply A1 over A2 is equals to 1 over 3. So what is the ratio here? The ratio will be 1:3. So look, I'll repeat. They mention in this question that both wires are made up of same alloy. Same alloy means same material. So if two wires or two samples, it's like this, like you have two samples of the wire which are made up of same material, same length, but they have different cross-sectional area. One wire is having a resistance of 12 ohm, another wire is having a resistance of 4 ohm. They both have the same length. We need a ratio of the area. If area of the first wire, I'm saying A1, area of the second wire, I'm saying A2. So I will use the formula R1, which is 12 here. A1, we don't know. And L1 is the length. It can be any number, but in the question they mentioned both have the same length. So I'm taking that as L. And simplify the ratio, like simplify this formula, I will get the final answer as 1/3. Is it clear, this question? Any doubt? This is another question. This is from May June 2013. Figure 9.1 shows a circuit that operate two headlights and two side lights of a car. This is the circuit which is used in the car. A 12-volt battery is there and the lamps are connected. Two of the lamp have a resistance 4 ohm and other two lamps have resistance 12 ohm. Switch A, this is a switch A. It can be connected to position 1, it can be connected to position 2, or it can be connected to position 3. So first they are saying, state what happened when a switch A is connected to position 1. Like if this switch is connected to position 1, what will happen? It will make any difference to the circuit? So it will not make any difference to the circuit. So what will happen? Position, when we connect to position 1, so you will observe all the lamps remain off, or lamps does not light up. If it is connected to position 2, if we connect this to position 2, it's here, like, what will happen? Which lamps will light up? All will light up, or some of the lamp will light up? Look what happened in this case. The conventional current is from positive to negative. So current will move from here. So current will divide here because they are in parallel. So current will divide. But you can see current cannot go back. So it will not flow through the branches of 4 ohm and it will return back to the battery. It will not flow to this position 3. So what will happen? The 12 ohm lamps will light up when it is connected to position. The 12 ohm lamps light up. Is it clear? Why the 12 ohm lamps will light up? Because they are part of the circuit. The 4 ohm are not part of the circuit. So no current is flowing through them. That's why only the 12 ohm lamp will light up. If it is connected to third position, if a switch is connected to position 3, what will happen now? Yeah, that's right. Now what happened? Only the 4 ohm lamps will light up. So here the 4 ohm lamps light up. State the potential across each lamp when lit. Means when the lamps are working, it can be any position, but if the lamps are working, you can see all lamps are connected in parallel to battery. So what will be the voltage across each lamp? So voltage in parallel is same. So if here is 12 volt, this will also receive 12. So each lamp will receive same 12 volt. Next, calculate the current in each of 12 ohm lamp. So we need a current in each. So the resistance here is 12, okay, and the voltage is also 12. So what is the current in each lamp? So if I'm finding current in each lamp, I will use V is equals to IR again. So I will take individual resistance and individual voltage and individual resistance. So voltage is 12, current we don't know, and the resistance is also 12. So then 12 divided by 12, what we will get? We'll get 1 ampere as. So what is the current will flow? Why it's of 2 marks? Why you will see 2 marks here? Because 1 mark is for the formula and the second mark is for the answer. For electricity here, so 1 mark, you will write V is equals to IR. When you write V is equals to IR, you will score 1 mark. And then you will substitute the value. This is 12. Current you don't know. Resistance is 12. And when you solve, you will get 1 ampere as an answer. That will award or give you the second mark. Next, show with a reason for your answer which lamp 4 ohm or 12 ohm has higher power. So how to get the power? So how to get the power? Yeah, that's right. And how you can work out this, because you have to show with reasons for your answer. Like you can calculate as well. How you can calculate? You can find a power. How to find a power? The formula of the power. Power is the product of voltage and current. When voltage and current are multiplied with each other, we get the electrical power. So what is the power of this lamp? How I can find the power of this 4 ohm lamp? First, what is the current here? We have the resistance,
48.
the current in 4 ohm. So we have the formula V is equals to IR. Okay. So voltage is 12 and the resistance is 4. So 12 divided by 4, that's equal to 3 ampere. So this is having 3 ampere current. And how much current was there? This was having 1 ampere current. Now how to find the power? The power is a product of voltage and current. So what is the power of this lamp? The voltage is 12 because all lamps receive the same voltage. So when you get the power of this lamp, it is voltage multiplied by current. So 12 multiplied by 3, the power of this lamp is equals to 36 watt. And when you find the power of the 12 ohm lamp, that's equal to 12 multiplied by 1, which is equals to 12 watt. Because you have to show by calculation as well, like which is having a greater. Theoretically, you mentioned the one which is having a smaller resistance will have higher power when they're connected in parallel. That's true. But you can also do calculation and show by calculation that which lamp is having a higher power. Yes, the 4 ohm is having a higher power in this example as compared to 12. So higher power means the 4 ohm lamp is much brighter as compared to a 12 ohm lamp. Like example, you can understand if I connect a filament lamp, okay, and I connect an LED, light emitting diode, and both are connected in parallel. This is small lamp or LED. When I connect both of them in parallel and I connect to a 12-volt supply, so what I will observe, the brightness of LED will be higher as compared to that of filament lamp. Because it is having high resistance, so less power, it will not be, it need a very high voltage to be same as brighter as LED. Is it clear, this question? Okay. This question refers to the quantities and the data. Yes, in the previous question, you can just show the working and you will get the full marks for that. This question refers the quantity and the data shown in the circuit. So what happened? These two are in parallel, but next to them, there is another resistor in series. Now, state a relation between I1, I2, and I3. What I can say about I1, I2, and I3 by looking at this equation? So basically what happened, you can see your current at your current split. So what you can say I1, the current I1 is coming from here, that breaks into I2 and I3. So how relation means here equation. So in terms of equation, what you can say I1, you can say I1 is equals to I2 plus I3. Is it clear? this equation because the current split in the branches, that's I1 equal to I2 plus I3. Is it clear, the first one? What we can say about I1 and I4, because what happened? I1 split into I2 and I3, and at point Y they rejoin again and it flow the same amount of current. So we can say I1 is equals to I4. Yes, you can also say I4 is equals to I3 plus I2 plus I3. But in the question, if you check the question, they mention relation between I1 and I4. So I need I1 and I4 relation. So my equation should involve I1 and I4. I can also say I4 is equals to I2 plus I3, but the question, I need a relation between I1 and I4. That's why I did not write this equation. I wrote directly that I1 is equals to I4. The next part, the ammeter read 0.8 ampere. Assume it has zero resistance. What is the potential between X and Y? So how we can find a voltage between X and Y? The ammeter, the current which is flowing through an ammeter is 0.8 ampere. These two are in parallel, but they are not parallel to battery. Before that, there's another resistor. So the voltage, because this circuit is not like, there's a difference between two types of circuits. Like if I have two resistors, okay, which are connected in parallel to each other, and the two parallel resistors or parallel combination is in parallel to the battery. So in that case, if this was a 6 volt, it should be 6 here and 6. But this circuit is not like when two are, because there is another resistor next to that. So this circuit example is two parallel resistors are there, and next to them there is a series resistor. So voltage across these parallel combination will be same, but that will not be equal to the voltage of the battery. So in this example, if I say this is a 6 volt supply, so they will not have 6 volt. Why? Because some of the voltage will be here, maybe 2 volts is here. So remaining 4 volts will be across these two. So there's a difference between, so actually this circuit which is shown is similar to this one. So what we will do, like example, you can see a 6 volt battery is there, but if you directly write 6 volt, that's wrong because there's another resistor next to it. So it cannot have the total voltage. So you can find that voltage. How to find that voltage? The current is given in the ammeter is 0.8. If current is there, resistance is there. So I will use the formula V is equals to IR. So V is a voltage which I am finding. I is a current 0.8 and R is a resistance 3. So 0.8 multiplied by 3, what I will get? 2.4 volts. So what does it mean? Because the two resistors are in parallel, So if two resistors are in parallel, it means both will have the same. Like if this was having 2.4 volts, this will also have 2.4 volts. Then what about the voltage here? What will be the voltage here? If total is 6, out of 6, 2.4 is dropped here. How much voltage across this R? Look, a current of 0.8 is passing. A 0.8 current is passing through a 3 ohm resistor. Voltage is constant throughout the parallel circuit, but this is not the complete parallel circuit, Salman. In this one, it is a combination of two parallel resistors connected to another resistor in series. So this is example. This is not a complete parallel circuit. It's a combination of parallel and series circuit together. So if it was a 6-volt supply and I found that 2.4 volts is across this resistor, same 2.4 volt will be there across the other. And out of 6 remaining, so remaining voltage will be there across a 6 volt resist this the second resistor. So if total is 6, 2.4 is here. We'll consider this as 2.4, not divide into, because they have the same. So this will be the voltage across the second resistor, which is in series. It will be 6 minus 2.4 only. That's equal to 3.6. It is because they are in parallel. Even I connect another resistor here. If I connect another resistor, that will also have 2.4. If I connect another resistor, that will also have 2.4. If I connect infinite resistor, all will have 2.4 volts. Basically, this part, I can connect infinite resistor, all will have or all will receive the same volts, because in parallel the voltage is same. So we don't take for all, we will only take for one part. Yes, Salman?
Sir, I know it's not, they're just connected to a series circuit,
Yes.
but the initial part is parallel only, right? So
Initial
like,
part is parallel. But
so shouldn't it still be 6
no,
volts?
what happened, like I will explain in terms of energy. Example, if it is written 6 volt, okay? So what does it means? It means that when one charge is coming, how much energy it carry? It carries 6 joules. Is it clear? The first part. Then it is
Yes.
flowing. When it flow, before entering, it was having 6, okay? And how much, as we just work out, the voltage was 2.4. So it means that the energy transfer or the potential difference is 2.4. So how much is left? That it will have 3.6 joules discharge. And when it will flow out, it is left 0 joules of electrical energy to transfer. Then there's another charge, because this is a parallel circuit. So there's another charge. So say this is a second charge. How much energy it will carry? That charge is also carrying 6 joules. When it enter the parallel circuit, like the first charge flow through the first branch, now the second charge is flowing through a second branch. Before entering, it will have 6. When it passes through, it will also have 3.6. So how much energy it transfer? It will transfer the same amount of energy. And when it will pass through the next resistor, it will distribute the same amount of energy. So these two
Sir,
are
why
in,
same amount? Why same amount of energy in the both
Yes,
resistors?
sir, it's
because
just 3 ohm. That's 2 ohm.
yeah, what is the reason why? Because the next resistor in series, so they need same amount of energy to cross this resistor. So both of the charges are keeping the same amount of energy, so they can pass through this resistor. Example,
So
this resistor was 100 ohm, and to cross this 100 ohm, the charges require 3.6 joules of energy. Example. So if one charge is entering here with an energy of 6 joules, so how much energy it should transfer so that it can have 3.6 hour before passing it through the another one?
Sir, 3.6 for the total one, or for one resistor only.
3.6 for this resistor only. So it's having a 6 joules of energy. When it passes through, it lose 2.4, because out of 6, if it lose 2.4, it will left with 3.6 joules of energy, and then it can have enough energy to cross this resistor. Same thing, another charge is entering, it required 3.6 joules to cross, and the second charge is initially having the same amount of energy, 6 joules. So when it tried to cross this, it should keep 3.6 so that it can use that energy to cross the other resistor. It's like a barrier. Resistors are like barriers for the
So,
charges,
sir,
so they should keep some of the energy so that they can cross the barrier. Otherwise, if they lose most of their energy in the first branch, then they don't have sufficient energy to cross the barrier. Yes.
so sir, what's the point in putting 3 ohm in the other resistor and 2 here?
Yeah, it does not make difference in parallel. This you are learning the types of circuit, different combination. That's I'm saying, if I connect any, like example, I connect a 100 ohm resistor here. Okay, I connect a
Yes,
200 ohm resistor, I connect a 50 ohm resistor. If they are connected in parallel, all are connected in parallel, the charges will always lose same amount of energy, because they have to transfer energy, or they have to cross the barrier next to that. So it is independent. I can have any resistor here, all will use same amount of energy.
So, sir, what if we put a bulb in the parallel
If you
circuits
connect a bulb here, example,
after
you,
the resistor?
which one? Which position? Here?
After no, in parallel circuit.
So if in parallel means like this.
Yeah, okay.
So the same amount, like example, it will also use the same. This was having 6 joules, because the thing is that the charges transfer energy according to whole circuit. When the charges enter, they this distribute their energy across each component. So it's not like, for example, if a charge is carrying 6 joules of energy and it enter this branch and it lose all of its energy, it cannot happen, because there is another component which they have to pass through. So charges does not transfer all of its energy if they have to pass through different components. They divide the energy into the components. Is it clear, the point? This is a circuit which is a combination of parallel and series. It's a mixed circuit. It's not series, it's not parallel, it's a combination. I will discuss this in next session. Less than a minute left.